The chapter redox reaction and rate of chemical reactions. So in the last class, all the previous classes we were discussing about oxidation and reduction, different types. How can we define oxidation using different methods? And what is oxidizing agent and what is reducing agent? Today we are going to talk about redox reaction, that is the chapter's name, that is redox reaction. Okay. Redox reaction. How can you explain about redox reaction? So here I am going to write an equation from the textbook. That is H2 plus Cl2 gives 2HCl. Okay, this is the equation. Now I am going to write the oxidation numbers or the charges. So I told you for the elements which are existing in the free state, we will be giving 0. The oxidation number of hydrogen is +1 and chlorine is -1. Now we are going to find out where oxidation is taking place and where reduction is taking place. So in hydrogen you can see that the oxidation number was 0. Before the reaction the oxidation number was 0. And it is increasing from 0 to +1. So here oxidation is taking place. Oxidation. Okay. But what about chlorine? The oxidation number of chlorine was 0, but now it has reduced to -1 here. See, it has reduced to -1. So here it is reduction. Okay. So hydrogen is oxidized and chlorine is reduced in one single reaction. So the reaction in which oxidation and reduction is taking place simultaneously in the same equation or in the same reaction, oxidation as well as reduction is taking place. That type of reactions are called as redox reactions. Okay, we will check one more example. Mg plus F2 gives MgF2. Okay, so here you can tell me the oxidation numbers of magnesium and fluorine. What are the oxidation numbers of magnesium and fluorine? Yes, very good, 0. What about this magnesium and this fluorine? The oxidation number of fluorine is -1 and magnesium is +2. So here the oxidation number has increased from 0 to +2. So since the oxidation number is increasing, the element in which the oxidation number is increasing, we can say it as oxidation. And the element in which the oxidation number is reducing, see, it has reduced from 0 to -1. So here you can say as reduction. So here magnesium is oxidized and fluorine is reduced. So the reactions in which oxidation and reduction is taking place simultaneously is called redox reaction. I hope it's clear for you what is a redox reaction. Next we are going to discuss about another topic, another new topic. You have been hearing about redox reactions for a long time. So now we are going to discuss about the new topic, rate of chemical reactions. Okay. What is rate? What do you mean by the term rate? Speed, isn't it? The speed in which a chemical reaction is occurring. So in olden days, now you can't see such situations, but in films you have seen, or in olden times if you go to your grandparents' house, you can see that there will be people who are using firewood for cooking, isn't it? So you have seen people burning air into it, isn't it? They will be having a pole with them and they will be blowing air into it to make the firewood burn faster. Okay, so you have seen different reactions around you. Like if you go to a lab, you can see the reaction between acid and a metal, you have seen how milk has turned into curd, then this burning of firewood. During Deepavali and all, you will be burning crackers. So I have given you so many examples. So from these reactions or from these reactions, can you tell me that all these reactions are occurring at the same speed, same rate? No, different reactions are taking place at different rates, isn't it? So when we buy these crackers, the moment we are burning them or we are lighting matchstick and we are burning them, it will be exploding and light will be coming. You can see what happens. Now, a curdling of milk, it doesn't occur in a span of a time. It takes some time to occur, isn't it? For that milk, the process should happen. The milk will be turned into curd. Then acid and metal. According to the metal we are taking, the reaction will be different. Then burning of firewood. So I told you in the beginning that for that firewood to burn, what you will do? Will you take that whole piece of log of wood and keep it in that fire hole? No. There will be people in the home who will be making it into small pieces. The firewood will be cut into small pieces, and those small pieces will be put into the fire hole. And in order for that wood to burn properly, what you will do? You will be adding kerosene for that fire to burn. After some time, when you see that it's not burning properly, wood is not burning properly, what you will do? You have seen people who will be blowing air into it to make you are giving oxygen, you are burning air into it to make them burn faster. So we are giving some conditions for the reactions to occur faster. So today we are going to discuss about certain factors which are influencing the rate of reaction. So normally 5 factors are there. First one is nature of the reactant. Second one is concentration. Then you will be talking about this catalyst, temperature, surface area. A lot of things are there which are influencing the rate of the reaction. So today we are going to discuss about the first 2 points, that is the nature of the reactants and concentration. So the first thing is nature of the reactant. So in order to explain about that, I am taking 2 metal pieces, that is magnesium and zinc. Okay, magnesium and 2 similar size metals, magnesium and zinc. One size ulla 2 metals. Okay, I am cleaning them properly. Okay, rubbing them and cleaning the surface of the metal very well. And I am taking 2 test tubes. Taking 2 test tubes. Okay, don't think that one is big and one is small, both are same. Okay, then I am adding acid. Okay, dilute HCl. Here also dilute HCl. Same quantity. Not a bit more, not a bit less, same quantity. So I have taken 2 metals of the same size, magnesium and zinc. I have taken 2 test tubes. The 2 test tubes are filled with acid of the same volume. Now, when these magnesium is added to dilute HCl, zinc is added to dilute HCl. When both metals are added to the acid, reaction is taking place, hydrogen gas is released. But when we are closely observing the reaction, you can see that the test tube in which zinc was added, the reaction was faster than, the test tube in which the magnesium was added, the reaction became faster. Why? I have taken same metals. Okay, I have taken the same metals, same quantity of acid, test tube, everything, has cleaned them properly. But when the reaction took place, I could find that magnesium, the test tube in which magnesium was added, the reaction was a bit faster than the one with zinc. Why? Because magnesium is a metal which is more reactive than zinc. Okay. So here what was the condition that favored the rate of reaction? Yes, the chemical reactivity of magnesium. Okay. So according to when you go to the higher class, when you go to 10th standard and all, you will be studying about this reactivity. So according to the reactivity, the capability of that metal, the ability of the metal to react faster. So here magnesium has a more ability to react with the acid quickly. So that's why when the reaction took place, I could see more reaction, or the better product, the more faster the reaction took place in magnesium. So the equations will be like this. Mg plus HCl gives MgCl2 plus hydrogen. Then zinc plus HCl gives zinc chloride plus hydrogen. See, the reactions are the same. Here I just took different metals. The acid was same. Both the gases released are same. But according to the reactivity, the ability or the nature of the reactant, the reaction took more faster in magnesium. So we can say that the nature of the reactant, how much reactivity the metal is showing. What is the chemical reactivity of the metal? Is it good or bad, or it is more or less? So according to that, the rate of reaction will be faster. So that is the first factor that is favoring the rate of reaction. Nature of the reactant. Okay, I hope it is clear for you. So that's all for this week. Thank you all of you and wish you a happy Puja holidays.
This chemical reaction will compare the reaction rates of two metals in hydrochloric acid, magnesium and zinc. Magnesium plus hydrochloric acid will yield magnesium chloride and hydrogen gas, and zinc plus hydrochloric acid will yield zinc chloride and hydrogen gas. We'll notice that the reaction rate of magnesium is much faster in the hydrochloric acid than it is of zinc in the hydrochloric acid. So again, I have magnesium here. It comes in a roll as a ribbon, and small pieces of it are going to be inserted into the acid solution. This is some dilute hydrochloric acid, and we'll look at the reaction rate. And the magnesium is gone. Similarly, if I take zinc, metal, these are mossy chunks or pellets of zinc, and insert that as well. We notice the reaction occurs, but it's much slower. And we see the bubbles of hydrogen being emitted over time. So this is a comparison of those two metals, noting that zinc and magnesium react both with hydrochloric acid, yet magnesium reacts much quicker.